So this is where Stoner CNC started back in '07 officially. Then we went official in 2013. So we'll stop and see where it all began. The shop's changed quite a bit in the past decade, but we got even cooler stuff in here now than what we used to. Hey, Dad.
Hi, Matt. How you doing?
Good. You want to give us a quick little tour of the shop?
Oh, you betcha.
I think people will be blown away.
Well, come on in. Come see the shop.
So it's changed a lot in the 10 years. We used to have a tool room there, and now we just got a bandsaw and a belt sander, big old drill press. Hey, Dad, what's that cool clock you got on the wall?
Oh, that was a retirement gift from that I worked at General Motors for 10 years or 20 years, and they CNC cut that for everybody that retired. And of course, well, there's mine. There's a number of other people that got those too when they retired.
So you guys were making, what, V8 motorcycles or V8 motors at General Motors?
V8s and V6s, heads and brake calipers and steering knuckles, all cast iron in the day. Just before I retired, they went to aluminum engine blocks, but at first it was all cast iron.
Okay. Well, it looks like you're still making V8 motorcycles, but we'll check that out in a minute. So what's this old thingy?
Well, that was one of the first machines I got, and that machine was made in 1959. So it's done a lot of work, and it still does a lot of work for me.
Cool. They probably didn't have that electronic screen there.
No, that's the digital readout, and it's a measuring device so that I know exactly where I'm at when I make things.
Okay. Well, looks like you maybe moved up from a Bridgeport to a Haas.
Oh yeah, that makes a lot of parts. But you know, a CNC machine is worthless unless you've got the software, and we've got good software.
So what do you got here on the left?
On the left, I made a Curtis 3-cylinder motorcycle engine from scratch. They were advertised. They were shown at the shows, but nobody has one. So I recreated one that's lent to the Curtis Museum in Hammondsport, New York, at the present time.
What's this thing over here?
Well, Curtis first made motorcycles, but then when he started getting into aviation, well, they found out that he made the world's fastest, most durable, lightest engines in the world. So this is essentially 4 V-twin motorcycle engines put together to make a V8. And so we'll look at the V8 motorcycle that I'm recreating too. And we'll talk about that here in a little bit.
Do you have the crankshaft or any of that modeled as well?
Absolutely. So we can take these and put them in what we call the body bag. And so I'm tearing the engine apart as we do this in the software. And cylinders go away. And then here we'll take the crankcase and put it away. We'll take the pan and put it away. So now here's just the crankshaft and the cam and the lifters and the lifter housings. So
you would have had to make all those components?
I had to make everything there. Now notice that it's a V8, but it's also got a flat plane crankshaft.
Well, flat planes are kind of making a comeback now, aren't they, on some of the sports bikes?
Yes, they are, because there's so little weight to them, and you can see that it's kind of spindly. This doesn't have the counterweights on it yet, but it makes for an engine that will spool up very fast. At the time, they were using a lengthened inline 4-cylinder crankshaft is what they did. But it was probably cheaper. Well, I know it was cheaper and more easily manufactured for the time to do a flat plane than a cross plane crank.
Okay, very cool. Let's keep moving, and let's. I think everybody wants to see the bike, but
Okay.
we'll delay them a little bit. We gotta tease them. Um, what are these things here?
Well, I make the head badges too. So here's a Curtis head badge. But to make this, I started with a piece of brass shim stock, and I did it in flat. And then here is the reverse mold that does the impression. So I take a piece of brass flat stock and lay it on here. Then I have a piece of UHMW, and then we put this in about a 500-ton press, and the UHMW kind of squirts out like Play-Doh, and then when we pull this off and pull it apart, then we've got this nice head badge.
Wow, that's beautiful.
Now, this has been, of course, nickel plated, and of course I've painted the lettering too.
Very cool. Does that say Stoner Motors on it?
Yes, it does.
You thinking about starting a real motorcycle company?
Oh, I made that just for fun, but yeah, I suppose I ought to put that on something.
Put that on the Cadillac.
Yeah.
So, what's this guy? Looks kind of like a small bicycle with an oversized motor.
Well, that's a 1909. I like the Curtis products, and that's a 1909 Curtis. It's in a race frame. Now it's called a Wayman frame. Wayman was the company that made it. The one over beside it is also a Curtis frame, but that's a standard frame.
What year are those?
Curtis made his motorcycles from 1902 to 1909. Then the brand name changed to Marvel, and but this is probably an 8 or 9, depending on how you want to look at it, or the engine that you put in it. There's some subtle differences throughout the years.
Those are very cool. Well, let's keep moving around the shop.
Okay.
So how did you make that crankshaft?
This is the crankshaft mold. It's called a match plate. So this is one side, and you have a wood framework, a box that has no top or bottom. And you put that on the sides, and then you smash the sand in here and get it packed. These make the locators for the other side. And so then if we flip it, you've got the same thing, and the protrusions back there will, when the sand's put together, this is called a locator. And so you've got the crankshaft. These are bobs that hold the extra molten metal until they want this to freeze first, and it will suck out of here to feed into the crankshaft so there's no voids.
How many of those crankshafts did you make?
Well, the crankshafts didn't go real well. We did other castings. The foundry, it took 3 tries before they got a good one.
Well, try and try again.
Well, be persistent, and it pays off.
And then, yeah, it's very cool.
This is all wood. It's a wood pattern. So the individual pieces were made to put on the board, but they have to be exact, and you have to allow for shrink.
Okay. So we were just talking about the crankshaft mold. This here must be the jug or the cylinder?
The cylinder. The cylinder's made out of billet, out of a material called Durabar. A friend has a CNC lathe, and he turned the cylinders out of billet, and then they have to go to the machine shop, and the center gets honed to fit the piston.
What's the bore diameter? That thing looks massive.
It's 3 5/8. It makes for a huge V8. The stroke is 3 1/4, so that figures out to be 4.8 liter or 270 cubic inch. That is a massive motorcycle engine.
Wow.
It is really an engine for a small automobile, but in this case, it was made for the motorcycle is just a test bed to test an airplane engine. These are air cooled and very light in the day
Wow.
for airplanes.
So these must have been some of the advanced motors that they had back in 1909.
They built the motor in 1906. They ran it was performed in the Speed Carnival in Florida at Ormond Beach in January of 1907. So the Speed Carnival had a number of motorcycles there. Curtis had a number of products there, but this was the most important one.
Looks like you do a little leather work.
Yes, and this is actually the stamp, and this is a practice part to make the seat.
Okay.
So at the present time, we've got a billfold here that we've played with this stamp.
Brass stamp. It's interesting the letters are on that backwards.
Yes, well, think about it. This has to get flipped over. But so if you want to read this, you can hold it in the mirror and see it, or here it is after it's been stamped in, and there you can read it. It's Miss Singer.
Yeah, very cool. Well, let's show them all what they came to see. So, Curtis, I haven't heard of that motorcycle brand. Is the company still around? And if so, what do they do?
Yes, it is. It's Curtis Wright now. That Curtis was like the Wright brothers. Started out with bicycles, but then as a bicycle repairman. Now later in 1902, he started making motorcycles. The aviation industry actually found him because he had the very lightest, most powerful, durable engines in the world, and the guys were buying his motorcycle engines and putting them in dirigibles, and then entering in contests and winning a lot of money doing the expeditions.
About how fast would have this thing went back in the day?
Well, the motorcycle was just a test bed to test out an airplane engine. It was only used once. I think Curtis himself was surprised that it made one run at a 136.7 mile an hour. Now, for the return run, it broke a drive shaft or something. So this is an exact recreation. It's the only running Curtis V8 in the world, and like I said, it was the motorcycle was only used for once as a test bed. The buyer was standing there to look at his engine and see it perform, and when the run was done, they immediately pulled the motor out, and then later they recognized that it was a really good advertising tool, so they the factory had some defective motor parts, and they put those in it, and that's what's in the Smithsonian at the present time.
That's pretty sweet. They had a drive shaft, so that would have been, was that uncommon back in the day?
Oh, very uncommon.
Looks like the alignment on that would be tricky to get those gears right.
Well, and it's not a 90 degree. It can't be a 90 degree because the center of the power comes off the center of the engine, the center of the bike, but then the drive shaft has to come to an angle to go to the side of the wheel. So the angle is 75 degrees.
Can you show us how the throttles work? Those look a little like, where are the cables? They just look a little different than...
Curtis was the inventor of the spiral grip. A lot of people think it was Indian, but no, it's Curtis. So this the cable goes through and it comes out the handlebar. It's hidden. So here's the throttle, and as the throttle works, the throttle moves backwards and pulls the wire that's inside of the handlebar.
Yeah, I can see the linkage opening up to give it a little more fuel and air.
Yes.
Does the other handle twist?
Yes, it does. This other handle runs the spark advance, as it's called, which is the distributor in the front of the engine. And so as I move this handle, it moves this. so that you can start it. And after the engine's started, then you advance the spark so that it's more efficient with the running of the motor.
That's interesting. So how much of this bike did you make, and how much of it did you purchase?
Well, obviously there's purchase parts. 90% of it I made. Obviously I don't make the tires or the rims or the spokes, but I made the hubs, the frame, the oil tank and the gas tank, the handlebars, not the grips. I did not make the carburetors or of course, the spark plug wires or the spark plugs, but everything else I've made. The heads have a 3D printed sand mold, and then the foundry pours the molten iron into the sand mold. The crankcase in the oil pan is also cast. Then, of course, the cast iron crankshaft is also cast. The heads are the only thing that use the 3D printed mold. Everything else has a wooden pattern.
Does this thing have brakes on it?
Oh, it's a crazy brake, and so we'll show it here. As the wheels spin, it's called a scrubber brake. You'd take your foot up off the foot peg, and then you'd step on this, and it would smash the tire like this.
I don't think that would pass the safety standard today.
No, well, they gave him 2 miles to get up to top speed, and they gave him a mile to stop it after they ran a full mile to make the run.
That would have been on hard packed sand?
Hard packed sand. Ormond Beach was known as the Speed Carnival. There was a Stanley steamer there running. There were cars and other Curtis products. He had a single motorcycle there, single cylinder, the twin cylinder motorcycle, and of course the V8. They did not have a category for his V8 motorcycle, but the organizers allowed him to make the run. Well, and it's unofficial because he was unable to make a 2-direction run.
About how much horsepower would have, what do you say, a 4.8 liter V8 make at this time?
4.8 liter V8, or it translates into 270 cubic inch. It is low compared to today's horsepower. It was rated at 40 horsepower at 1800 RPM. Now the math figures out that the motor would have been turning 1,675 RPM to do the 136 mile per hour. So it was geared directly. So the RPM of the engine is the RPM of the rear wheel.
Wow. Well, what do you think, guys? I don't have any more questions, but this is truly incredible. Dad, thanks for showing us the shop. I think.
Thanks for coming by, Matt.
Yeah, cool. Maybe we'll do some future projects together and post those on the internet.
Okay.